visualization of subsurface data is often best accomplished through cross-sections and fence diagrams. And this video shows how this now can be achieved in 3D Analyst. Now what you see here is 3D borehole point data, and if we take the tops for each stratigraphic layer, we can create so-called horizons through these 3D points. And then we can extrude between these horizons to create a block diagram. And this block diagram represents rock volumes. And now our new 3D vector capability allows us to slice through these rock volumes in a number of ways. So here's an example of a fence diagram, or we can also cut this rock volume, and the end result would be cross sections. So another example of our new 3D vector analysis capabilities.
Be sure and look at the new tutorials for the 3D Analyst, because I think you're going to find a lot of ways that you can use the new capabilities. I want to talk about imagery, and GIS users use images as backdrops, as checks for where we've located our vector data, but I don't think we're using the power. It's not just a pretty face where I can do some heads-up digitizing. There's much more information available through remote sensed images. There's also more and more data available and more resources to know about them. The USGS Global Visualization site, and if you just Google global visualization, you're going to come up with this site, and it looks like the window on the right. You can pick your study areas by date and which Landsat you want to use. In 2001, Education downloaded 2,000 Landsat scenes. In 2009, when it became free, they've downloaded 357,000 scenes. And in 2010, I think it's going to grow perhaps by an order of magnitude. Not only that, in education, you often have your local government has data, remote sense data. They may have LiDAR data, MODIS. You can also access ASTER data. So look at vendors who have high resolution or hyperspectral data and see if there is a way for you to use some of their data in your educational programs. Things have really changed with ArcGIS 10 for remote sensing and imagery. Many of these tools were there and the functionality was there, but it wasn't easy to access. Now I showed you quickly the image analysis dockable window, but I'm going to go through exactly how to use it and what to use it for. You can clip large images. You can take images if you've got several that, your project is always in the middle of two. You can create a seamless image. You can create a new type of data format called a mosaic data set, and I'm going to talk about that in a minute. You can create composite multiband images from the different Landsat bands, and you can do NDVI, Normalized Difference Vegetation Index, which is used in land use change in agriculture. How green is your vegetation. The last one here is image classification toolbar. When you bring in your vector, your raster data sets, your pixels all have values for the data that's being displayed. You can clump those into like types of reflectance using a tool called unsupervised classification. The software just goes out and says, oh, all those pixels are this value, put them into one group. You can do a supervised one where you tell it and create what's called a signature file and have it put it into classes that you specified. This is really useful because you can then reclassify this and use it for change detection over time. Just a real quick, so you kind of know what I'm doing next. Landsat scenes come in with 7 or 8 different bands of data, and sometimes you see the word bands and sometimes you see the word channels. But really what